Hi, welcome back. In this video, we're going to talk about how to factor a quadratic with no GCF. What does that mean? In a previous video, I showed you how to graph or how to factor a function that looks something like this. Notice how in this quadratic, to factor it, they're all divisible by 2. So we factor out the GCF, the 2. And when you divide everything by 2, you're left with x squared, positive 5x, and positive 4. We're able to pull out a greatest common factor and then factor this simply. And I showed you the column method that I like, x times x, 4 times 1, we cross multiply, right? All of that jazz. And we're left with 2, x plus 4, x plus 1, where there is a GCF here that we're able to pull out. Well, today I want to show you how to factor quadratics that do not have a GCF. Examples like these, right? Here, I don't have, not every value here is divisible by 3, or all divisible by 2, or by 3 here, right? I have scenarios here that do not have a GCF. Now, I'm going to do the same method, right, where I break this into columns, except that now, instead of just being x times x to get x squared, we're going to do 3 times 1 to get that 3. Now I have to consider another number here. Now for this piece, I'm going to do it in pencil because I'm going to potentially erase some things. I'm still going to do the factors of 5, which is 5 times 1. Now, if I multiply, say 1 times 5, and I cross multiply for my method, to find the factors of 5 is just 1 times 5. As I cross multiply, notice how 5 times 3 is 15, and 1 times x is 1x. There's no way I can combine these two to get a negative 2 from there. And because now I have a term in the front, I have to be careful with where I place the 1 and the 5. So instead of 1 times 5, I'm going to change this to 5 times 1. And as I cross multiply, 1 times 3 becomes 3x, and then 5 times 1x is 5x. Now, if I wanted to combine these two, in order to get a negative, the 5 must have been a negative. 3 minus 5 is negative 2. Right? Now I have to pay attention to this. When I cross multiply, you got to consider the value in the front. So if this was a negative 5, it means that it must have come from this value here. So what are my factors? Again, the middle column is just to check your work. The outer columns are our factors. 3x goes with the negative 5, 3x minus 5, and the 1x goes with the positive 1, so x plus 1. Let's try a few more together. Again, I cannot factor out a 2 from all of the terms. These two both have a 3 in common, but all the 3 terms have to have something in common. So since there's no GCF, this means we have 2x times x. X times x is x squared, and 2 times 1 is 2x squared. How do we get a 9? Well, for 9, we get 9 times 1, or 3 times 3. I'm going to have to experiment. Let's try 9 times 1. When I cross multiply, 1 times 2 is 2x, and 9 times 1 is 9x. Notice how I'm not able to get a 3 from these. 2 minus 9 or 2 plus 9 does not give me 3. Well, let's try, instead of 9 times 1, let's try 1 times 9. A lot of this is experimentation, right? You have to try and process things out to see what's going to work. 9 times 2 is 18x, and 1 times x is 1x. Here, if I add them or subtract them, I still cannot get a 3. Therefore, it must not be 9 times 1. Let's try 3 times 3. I like to do these with pencil because I'm going to have to experiment and try different solutions. Let's do 3 times 3. When I cross multiply, 3 times 2 is 6x, and 3 times 1 is 3x. The only way I can get a 3 from here is if I do 6 minus 3. That gives me a positive 3 in the middle. Now, since I subtracted 3, remember how this came from the top? It was 3 times 1. That means that this negative must have come from up here. And now I can group my factors. The middle column is just to check your work, right? 2x minus 3 is my factor. And my other factor is 1x plus 3, because it's positive. Why don't you pause this next one and see if you can get the same thing as I do. I have 3x times x, or 1x if you prefer, right? 1x or just x, it doesn't really change anything. To get 4, we got 2 times 2, and we have 4 times 1. Let's experiment. If I have 4 times 1, when I cross multiply, I get 3x here in the top, and then I get 4x from here. When I add these or combine these, I get a 7. I don't get an 8. So let's try the other direction. Instead of 4 times 1, let's try 1 times 4. And let's cross multiply. 4 times 3, I get 12, and 1 times x is 1x. I still don't get an 8. 12 minus 1 is 11, and 12 plus 1 is 13. So I can't add them or subtract them to get 8. So it cannot be 4 times 1. It must be 2 times 2. Let's try it out. So now I have 2 times 2. When I cross multiply, 2 times 3 is 6x, and 2 times 1 is 2x. The only way to combine these two to get a negative 8 is if they're both negative, right? Negative 6 plus negative 2 is negative 8, which means both values must have been negative. And that checks out, right? Negative 2 times negative 2 is still positive 4. And when you add the two negatives, you get negative 8. So what are my factors? This is just to check my work. My factors will always be on the outside. I have 3x minus 2 and x minus 2. We can do more examples if you like. If this feels like it's a good enough or a good pausing place for you, don't forget to like and subscribe. If you would like to do a few more examples, stick around. In the end, how comfortable are you? So what I recommend you to do is press pause and check it out. What values are going to get me there? Right? How do I experiment to get that middle column to be 19, to get 11, to get 5? 5x times x. Now, 12 gives you 6 times 2, 12 times 1, 3 times 4. The more you practice these, the faster you're going to be able to get at recognizing the patterns. I'm going to focus on 3 times 4. And specifically, I'm going to focus on 4 times 3, because I know 3 times 5 is 15x, and 4 times 1 is 4x. That's how I'm going to get that positive 19 from the two combinations. But if you have to go through all of them to get there, feel free. This is just practice. The more you do it, the faster you get at identifying. The factors are 5x positive 4 and x positive 3. Try another one. 2x times x gives me 2x squared. And then I have 5 times 1. Where do I put the 5? Where do I put the 1? Well, I'm going to put the 5 on the bottom because I already know I'm going to get 10 from here. And 1x from down here. And notice how these add up to a nicely positive 11. Yeah? My factors are always on the outside. 2x positive 1, or 2x plus 1, and x plus 5 since they're both positive. Alright, last one. Again, I'm only able to do these comfortably because I've done a lot of factoring examples. So the more you're willing to do these, and I know you are if you're still watching this video, is the more practice you get doing it yourself, not watching the video, but pausing it and trying it, is the better you're going to get at these problems. You'll start recognizing which combinations work with what. Like 2 times 1, where do I put it? Do I put the 2 on the bottom, 2 on top? I can start to mentally do some of the work right here with 2 times 1. Then I'm going to do 1 times 2, because 2 times 2 is 4, and 1 times x is 1x. And that's how I get to 5. Right? To get more comfortable, you just need more practice. And the factors are 2x, positive 1, x, positive 2. If you are struggling with the method in general, go watch my other videos that says how to factor a quadratic when a equals 1. Start with factoring quadratics when a equals 1. Start with that. And then go where a is equal to 2 or 5 or some other number. Don't forget to like and subscribe. And as always, we'll calculate.